All right, welcome to EE391 MM391. This is maintenance, reliability, and engineering economics. Welcome to this afternoon's lecture session. Uh, we will continue from the point where we were yesterday. Um, I will now share my screen. I will now share my screen. Okay. All right. Can you please confirm if you can? Can you please confirm uh, if Bhavish and Hafiz? Can you guys confirm if you can see the screen? Hello. Okay. Can you guys confirm that you can see the screen?
Yes, sir.
All right. So welcome to our this afternoon session. Let's start off straight away. You should see my Word document. Okay. What were we doing yesterday? We were looking at this problem, but before we got to the problem, I wanted to explain to you how to go about some of the rules with regards to this. So the rule is that firstly that G has to be linear, right? G has to be linear. It has to be gradually. It has to gradually or constantly increase or decrease, and the G has to start from $0 and at interval number 1. So interval 0 it's going to be 0. From interval 1 it's going to be 0, and then it's going to start off. So we want to find the present value over here. We want to find the present value. What answer did you guys find?
7159.8.
Yes, that's correct. uh, 7159, or was it 7,000? Did anybody get 7004? Wait, what's the interest rate? 6.5%, right?
7159.88.
7159.88. Okay. All right. Guys, somebody has to. All right. 7.159.88. All right. Okay. That is the answer. Now, um, um, there's another way of doing this. What we usually do is another particular concept. Another particular concept is, and let me just draw this out, is convert we convert this annuity we convert this annuity into we convert this annuity I mean this gradient, this arithmetic gradient, we convert it into a into an annuity. We convert it into an annuity. So let me show you. Okay, all right. And what we are trying to do over here is we convert this particular what we have over here, which was our gradient, we convert it into an annuity. All right, we convert it into an annuity, and that's what I'm trying to show you over here. And you have some value of a, right? So what we want to do in the end, what we want to do in the end is we have what we would like to do is we would like to convert this gradient into this. So let's go ahead and do that. Insert the picture. Okay, in the first instance, we attempted to solve the problem. The first time around, we attempted to solve the problem by finding P using, right? Okay, so first attempt, in the first attempt, we 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 try to use, we tried to use the P given G, right? But a more generally accepted approach, a generally accepted approach, a more generally accepted approach, because if you look at that formula, right? If you look at the P given G formula, if you look at the P given G formula over here, the P given G formula as follows is very big, right? Okay, so a more generally accepted approach is to first convert the G into an annuity, right? Like what we did on the right hand side. Okay, okay. We want to convert the G into an annuity. As shown below. Okay, and then find the P, the present value. So we want to convert this guy here into this. Okay. All right. So what do we use? What formula would we use over here to convert the G into A? How do we find the A? How do we find the A? Anyone? Let's see your thing. What would we use here? Anyone? What formula would we use? Yes, we would use A
Use
given
A given G.
A given G. Yes, that's right. Thank you. All right, A given G. Okay. Now for A given G, the what are our variables? Well, we would have let's see. So our A will equal to G into A given G, right? And we have $250, which is our G, and we want to find our A at 6.5% 10 years. So now I want you to go into your formula sheet. I want you to go into your formula sheet and find for me what is the particular A given G formula, right? Let me just quickly try and find the formula, right? So remember, we'll always use the same formula sheet. It's a standard formula sheet. We want to use A given G. Okay, so these are all the G. Let me just give all the G formulas over here. There we go. Those are all of G formulas. So what do we get? We want to use this last guy over here. These are all our G formulas, so we don't have to flip back and forth. So let me put this into a particular thing. So our A will equal to let me use an equation editor over here. What is our G? Okay. A will equal to that is our G multiplied by, and then we have 1 over I right, minus, and then we have N 1 plus I to the power of N, and then that's minus 1, and we say that goes to the power of N, and we have this here. Okay, all right. Anybody found any errors? Is that formula looking okay? Okay, so let's go ahead and calculate this. What is our G, guys, in this case? What is our G? All right, some people have already started to calculate the answer. Thank you, I like that. Our I is 6.5%. Okay. Our N is 10 years. And finally, our answer is 995.97.
995.97.
Yes, 995.97. All right, okay. Now, by the way, who mentioned the 995? Somebody came on the mic and said it. Who was it?
Hey, James.
James. Okay, James. Just say James. Okay, so that's all right. So that I can record your points. All right. Right now that we have got A given G, now that we have A, we can then convert the A into P. So what formula would we use, guys, in order to find P in this case? Remember, we wanted to find P. So we went from here to here. In the first instance, we did a direct conversion. In the second attempt, okay, second attempt, right? We went from G into A and then find P, right? So we have to use P. We will find by P given A, all right? P given A. Okay. By the way, I've forgotten something over here. I should put today's date, right? And I think I forgot that yesterday as well. Let me just put this down. So what was yesterday? What was yesterday's date, guys? 1st November.
Yes.
Yeah, thank you. And week 11 lecture 1. And today's one is, okay, we can just say this is part of today's one because that's basically the main question we will be doing today. Okay, 2nd November, week 11 lecture 2. All right. Now, P given A, right? So P given A is the way we will calculate P is equal to, you have your A into P given A, comma, I percent, comma, n years, n intervals, which is equal to, what is our A in this case? Our A, we have found it to be $995, right? $995, and then we want to multiply it by P given A factor of I percent is what? What is our percentage over here? 6.5%, and our thing will be, our intervals will be 10 years. All right, and let's now go ahead and calculate it. So our P, we have our A, and what formula do we use? P given A. That goes somewhere back over here. P given A, right? Sorry, I used the wrong formula here. Some guys are P given A, and we have an A. What is our A in this case? It is $995, right? And this is 0.0065, 0.065. Am I using the right formula, guys? Am I using the right formula? Okay, and all right, and the answer is 7,100. Now, does this answer match before? Does this answer match the previous case? Yes. So match between attempt 1 and attempt 2. All right. Let's now, maybe I should have put this problem 3 arithmetic gradient. Okay, let me just put that there. Arithmetic gradient. Okay, now let's go ahead and do the question now, guys. Up till now, I was just showing you how to use the formula, but it's not easy. This question is complicated. Okay, now let's do this question now. All right, Now, we had already drawn the cash flow diagram. Now, if you look at this and look at our example to explain this thing here, right? If you look at this cash flow diagram, right? What did we find? We said that, hey, it's going to start at 1. But where is this guy starting? Where is this guy starting? It's starting at 0. It's starting at 0. So what do we have to do? Well, basically we have to convert this diagram. So I'll show you what we've got to do. Okay, let's draw something again. Yes, we've got to split that diagram up into two pieces, right? We've got to do a split into two pieces. So basically, we take this. I'm just gonna make it slightly smaller, right? Okay, and we're going to split that into two pieces. So I'm going to draw a drawing. I wanted to save some space on the right hand side. Okay. Okay. So we have this diagram will become something like, it will become something along these lines. Let me show you. One, two, three, 4, 5, and then we have a big plus sign here. Okay, we're going to split it into two things, and we want to have an equal sign there, big equal sign. Okay, and there'll be another diagram over here. One, two, three, 4, 5. Right, put some text there. Okay, so we have arrow color red going downwards. We want to find the present value over here. We want to find the present value over here, right? And this guy here will have some annuities, right? Some annuities. Okay. And this guy here okay, and we call this 0, 1, 2, 3, 4, 5. Okay, and exactly the same. Okay, then we have the same thing over here. 0, 1, 2, 3, 4, 5. Okay, now we want to have something called P1 over here, P1, and this is P2. So I want you to take note over here what I've done. Okay, this is a very important part of the problem. Unlike before, so we have an annuity here, we have some annuity, and this annuity is equal to $120. $120, all right? And we have a G of, how much was the G? Of $30. It increased by $30. Okay. Now, I want you to see what I've done over here. I want you to take note of what we have, what we are trying to do, what I'm trying to show you in this particular case. All right. So can you see this original diagram? What was the problem? If you look at the original diagram, the problem was that it was starting at, the problem is that it was starting at 0. So how can we rearrange it so that it comes into this particular thing, right? How can we rearrange it so that it starts at 1? So basically, if you look at it, you'll see that this is actually an annuity, and your gradient, your arithmetic gradient, is actually sitting on top of your annuity. Yes, your A, that's Terence, you're right. Okay, and Pranil, you got it as well. You are what do you call, you've got it right. Okay, so that's A. Your A is your base amount, right? Okay, let's just roll up over here. Let's roll up over here and look at the original question. I mean, the example which we did. According to the rules, your G has got to start at interval number 1. But it seems that the G in this particular question had already started at 0. Had already started at 0. Okay. Okay, so let's go ahead and do this. Let me just insert that diagram. Okay. All right. So the G, if you look at it, right? Now when we put it in this particular configuration, right? So this particular diagram, the first one on the left, we got from the question. And we have to split it up accordingly in this way. So in the end, what we find is that our, in order to find P, we learn that, present value in this case, we find that we have to do P1 plus P2. All right. Okay. So we have to split it. Okay. Now let's go ahead and calculate P1. How do we calculate P1? How do we calculate P1, guys? Anyone? We will calculate P1 by using P given A.
P given A.
Yes, P given A. Who said that? Okay. Who said P given A on the mic? Was it James? All right. Okay. Okay. All right. Okay. Now P given A. So in order to calculate our A, we use, let me just copy some of these formulas because we are recycling some stuff. Okay. Our P given A. All right. So what is our P in this case? I mean our A. Our A is 120, P given A. What is the percentage interest in this case? Was it interest rate given? Was it interest rate given, guys?
No.
Was it interest rate given? No, the interest rate was not given. Okay. Okay, let us assume an interest rate, guys. Let us assume, maybe I'll just put it right below the question over here. Assume interest rate of 5.5%. Okay, so interest rate of 5.5%, and we have n equals 5 years. All right, so what we have here, we put 120, we put 5, that'll be 5 years. Okay, 0.55, 0.55, we say 5 years. Okay, what answer do we get, guys? What answer do we get?
So just a question.
Yes.
I understand we took it as in 5 divisions and so, but the annuity that we're taking for 120, it's for 1 year, or will it be for 5 years?
Sorry. Repeat your question. Repeat your question again.
Because like in the first year it's 120, but then we
Yeah.
don't really, before that the 120 annuity that we're taking, is it for 5 years or is it just for 1 year?
It's 5 years. 5 years. See, look at this. This is where the catch is. The catch is this. Our cash flow diagram is this. Everybody agrees that it's this. First year, no maintenance, zero. I mean, when you bought it brand new, on the day you bought it, there was zero maintenance, $0. Yeah. First year, the maintenance came to 120, right? So therefore, and then second year, the maintenance came to 150. Okay, but in order to deal with the G, we can't deal with the G of $30 per year starting at 0. We've got to split it. Why do we have to split it? Because according to the rules, let's have a look at the rules over here. According to the rules, the G is going to start at 1. The G at first year is going to be 0. You're saying that ramp, for those of you doing electrical engineering, that ramp has got to start at 1. Yeah, and the first year is going to be 0. So it's going to start, just like how annuity always starts at 1, the ramp has got to start at 1 as well. All right, okay. So in order to bring it into that particular formation, we have to split this guy, the guy on the left hand side, we have to split him up into 2 pieces. We have to split it up into 120. Can you see that 120 has already occurred in the first year? So 120 is already there. And then if you look at it from a geometric point of view, from a purely visual point of view, if you join these 2 diagrams, if you add these 2 diagrams, they actually start to look like this. Yeah. Does that answer your question? So that's why your annuity starts at first year and it goes till the 5th year.
Okay.
Okay. All right. Now, okay. So Tavake. All right. Some guys have got the answer. That's your 512. So this was actually P1, right? Okay. Now let's go ahead and try and do P2 now. Now, in order to calculate P2, the way to calculate P2 is we can use P given. We can convert from the G. We can find A given G, right? A given G. So we find A. Let's call this A2, right? And we use G. So I'm using like what we used over here in our second attempt. I'm using what we used over here, all right? Okay, A given G. So our G, and let's call this A2. I'm deliberately changing the value, right? Our G is, what is our value of G, guys? The value of G is $30, right? And that was 5.5%, and our timeline is 5 years. So I'm going to call this A2, right? Okay, to find A2. In order to, and what we are doing, we are trying to find P2, right? Our calculations over here are in line to calculate P2. So we first find what our A2 is. We use the A given G formula. Our A2 is that, so this is 30. I'm just going to do some changes to my thing. 55 0.55. This is 5. That is 5. What do we get, guys? What is our A2 over here? Let's see. A2. What is our A2? Anybody found A2? A2. I'm giving you a chance. A2, guys. A2? Anyone? Come on, guys. Let's plug that in. I'm waiting for your answer. I'm waiting for your answer, students. Anyone? What is our A2? $56.79. Okay, I trust your answer is correct. Okay, now, after we've calculated A2, now, from A2, we then calculate our P2, right? So what formula do we use? P2, what formula do we use? We use P given. We use P given A. Yes, John got it right. So that's P2. We have to plug in our A2 over here, right? And our A2 we have just calculated just 2 minutes ago, which is $56.79. Okay, 5.5%. Is that right? 5.5%? 5 years? Okay, and so we have P2, we put in our $56.79 here. 5, everything is the same, everything is the same. What do we get here, guys? Answer. Answer. What do we get? You know what I'll advise you guys to do? I don't know if you know how to code. I mean, you should know as an engineer. You should know. You have your MATLAB program ready. Listen to this. I was going to give this as an assignment, but I thought everybody in a coding assignment copies anyway, right? So you have your MATLAB program, code a MATLAB program. Listen to this idea. You copy your MATLAB program. I mean, write a MATLAB program for all your different formulas. Remember, how many formulas do we have? Let's have a look at it. We have 3 formulas to do with G, and then if you go earlier on, 1, 2, 3, then I think in your formula sheet we have all together. We've got 4 over here, 3 plus 4. I think 9 formulas altogether. We have 9 formulas. All right. So what we do is you can code your 9 formulas, and all you got to do is you just punch in the interest rate, punch in the annuity, punch in this, punch in that, and tang, your thing should calculate your your particular thing for you. You don't have to go ahead and calculate it. So because you're doing an online exam anyway, you're going to do an online exam, an online short test anyway. So that is how a real engineer would work. All right, that is how a real engineer would work. Okay, Guys, just give me a second over here. I don't know what's wrong. Hello? Yeah. Yeah. Afternoon time, okay? Okay, bye. Bye. 3 o'clock. 3 o'clock, bye. Alright, guys, sorry, apologies for that. Okay, in the end, P1 plus P2 is equal to, what do we get, guys? P1 plus P2 will equal to $754.95. P1 plus P2 will equal to $754.95. Oh, yeah, 95 cents. Okay, so that's how we go ahead and solve that particular problem. All right, but it is very important that you visualize this. Now, if you were to alternative way, I mean, if we wanted to use sorry, if we wanted to, um, if we wish to directly, right? If we wish to directly calculate the P2 using P given G, what answer do we get, guys? What answer do we get? Let's see. Let's see if we wanted to use the P given G. Same answer? Yeah, using P given G. If we use P given G, what answer do we get? You should get the same answer. You should get the same answer, right, for P2, which is $242 and so forth. Okay, guys, any questions? Any questions which you wish to raise? If there's no further questions, I think
Sir Futaran.
yes, go ahead.
So we did the write up like we used to post for each week. We have to write the example again, or we just submit up in words.
I didn't understand what you're trying to say over here, uh, James.
If because we have to submit like you have told us to do. So
Yeah,
if
yes.
for the submission, do we need to write the example or we have to write a
No,
summary
no.
of the
See, here, guys. What you do for the example is you can just write down the example number, the problem number, or whatever. You don't have to write the question. But remember, you can even copy and paste the question. I've provided all these questions are on Moodle. It's like a question paper of all the questions are already uploaded onto Moodle. Right? There's a PDF document. So you can insert the image of that somewhere, or you can write it down, or you can just simply write down problem number 3, arithmetic gradient, and start solving the problem. Okay, you don't need to necessarily write the question, but make sure that you have enough information there so that when you do your revision from your exercise book, you've got enough information there. Okay, all right.
So for the submission, it's okay that we only write a summary, not the
It's
calculation.
summary. Yeah, summary. Because summary is mostly calculations. All we are doing is we are calculating in this thing. There's not much theory, right? There's not much theory in this particular course, in this particular side of the course, all right? Okay. Um, okay. If there's no further questions, guys, I'd like to stop the particular discussion there today, so that yeah, we'll finish off with that this afternoon, and we'll continue on Friday, and I'll give you an early off today. It's already 45 minutes into the lecture, and thank you for attending the E391 MM391, and I wish you take this opportunity to wish you a prosperous and happy Diwali. All right, and we'll see you after Diwali on Friday. Okay. All right, guys. In the meantime, if anybody has got a question, I'll just hang around for 5 or 10 more minutes. But otherwise, we are finished from this afternoon's lecture. Please make sure you you revise this particular how we attempted this particular problem. Right? That's it for this afternoon. Thank you for attending, and we'll see you on Friday.
Thank you,
Goodbye.
sir.